So prior to now, we looked at law of indices, the first law of indices, and we told ourselves that suppose we have x raised to the power of a multiplied by x raised to the power of b, the answer will be x raised to the power of a plus b. Also, it is not restricted to variable x alone. If we have, let's say, y raised to the power of n multiplied by y raised to the power of n, the answer will be y raised to the power of n plus n. And that is how it is. This is called the first law of indices. And we demonstrated some examples in the previous class. Examples such as, say we have 3 raised to the power of 5 multiplied by 3 raised to the power of 7. The answer will be 3 raised to the power of 5 plus 7, and the final answer will be 3 raised to the power of 12, because 5 plus 7 is 12. So that is like a recap of what we did in the previous video. If you have not watched it, go back and check. Now this exercise, or the whole of this, is not restricted to JSS1 to JSS3 students. Anybody can actually, but it is more specific. We're trying to make it specific to the needs of people who are in these classes, but any other person can watch and enjoy the benefits. All right, so today we want to look at the second law of indices. Now the second law of indices says that if you have, let's say, x raised to the power of a divided by x raised to the power of b, right? Or let's say it is x raised to the power of a all over x raised to the power of b, whichever is the same thing. The final answer will be x raised to the power of a minus b. That's the beauty. Now let me put it well. Whether it is x raised to the power of a divided by x raised to the power of b, the answer will be x raised to the power of a minus b. Or it is x raised to the power of a all over x raised to the power of b, the answer will be pick one base, x raised to the power of a minus b. So whichever form that the question comes, whether the question comes in this form or the question comes in this form, the answer will still be the same. Now these are some examples. Let's work out some examples exercises. Let me take the first one. Suppose you have 4 raised to the power of 5 divided by 4 raised to the power of 3. What will it be? Answer will be 4 raised to the power of 5 minus 3. Final answer will be 4 raised to the power of 2. That will be your answer in index. Now, let us assume that this is second question. If we have 3 raised to the power of 11 minus, or rather divided by 3 raised to the power of 8. Going by the second law of indices that tells us that x raised to the power of a divided by x raised to the power of b will be equal to x raised to the power of a minus b, and this will also be equal to 3 raised to the power of 11 minus 8. The final answer will be 3 raised to the power of 11 minus 8, that is 3. 3 raised to the power of 3. This will be the index, and that's the final answer. So that's the second law of indices. Now let me take my examples. I call it example number 3. Suppose you have 5 raised to the power of 3 divided by 5 raised to the power of 2. Okay, 5 raised to the power of 3 divided by 5 raised to the power of 2. What will be the answer? The answer will be 5 raised to the power of 3 minus 2. That will be 5 raised to the power of 1, or just 5. Because any number raised to the power of 1 is that same number. Now let us do some composites. When I say composite, I want to merge the first law, law 1, and law 2 together. Merging law 1 and law 2 together, let's assume we have this question. I'll call this exercise 4. If we have 2 raised to the power of 3 multiplied by 4 raised to the power of 2 multiplied by 16 all over 32. How are we to solve this question? Now, in order to solve this question, if you look at it, you discover that we have a combination of multiplication and division. Why do I say division? Because this all over can also be used to represent division. And like I mentioned, while trying to explain the first law of indices, if you have question in this form, you discover that their bases are different. This is base 2, this is base 4, this is 16 as a whole number, this is 32 as a whole number. So they have different figures. The smallest base is base 2, so you have to reduce the others to base 2. To do that, you have this. Let's say solution now. Solution 2 is the smallest base, so 2 raised to the power of 3 retains, multiplied by, open a bracket for 4. 4 is the same as 2 raised to the power of 2. Close it. 2 power 2 is 4. Don't forget there is a power 2 outside, so you bring it out. Then multiply by 16 is 2 raised to the power of what? Now I will not just write it, I'll show you. If we have 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. If you count the number of 2's, 1, 2, 3, 4, so that's 2 raised to the power of 4, will give us 16. Then for 32, that will be 2 raised to the power of what? If we go by this, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, that's 32. If you count the number of 2's, 1, 2, 3, 4, 5, that's 2 raised to the power of 5. So let us express this properly. It will be 2 raised to the power of 3 multiplied by 2 raised to the power of, the power will multiply power like I explained in the previous video. So that is 4 multiplied by 2 raised to the power of 4 again, all over 2 raised to the power of 5. Now let us work with the numerator. Applying the first law of indices for the numerator, you have 2 raised to the power of 3 plus 4 plus another 4 all over 2 raised to the power of 5. So what will this give us? This will be 2 raised to the power of the previous numbers, 3 plus 4 plus 4. 3 plus 4 is 7, and 7 plus 4 is 11. So that's 2 raised to the power of 11 all over 2 raised to the power of 5, right? So this will also be equal to, applying the second law of indices now, 2 raised to the power of 11 minus 5, and that will give you 2 raised to the power of 6. So this will be the final answer for that question. Do you understand? If you really do understood what I explained, then you can try this on your own. First question is 4 times 3 raised to the power 2 times 4 raised to the power 6 all over 3 raised to the power, oh, beg your pardon, let me make this 2. 4 times 2 raised to the power of 2 times 4 raised to the power 6 times 2 raised to the power of 5. I hope that is clear. And I'm giving you this one, 16 times 8 times 2 raised to the power of 9 all over 2 raised to the power of 13. Let's see what you can make out of this. So try this too, and let's see what you'll be able to do with them. Thank you.